Hi, I'm Bob. Welcome back to the 5 Minute Econometrics, an econometric tutorial on fundamental concepts and estimation approaches. In today's topic, we will take a look at the difference between the population model and the estimated model, and the difference between the error term and the residual in a regression model. We can write the population model as yi equals beta 0 plus beta 1 times xi plus mu I, where the subscript I represents the i's observation. Mu I is the error term or the disturbance of the i's observation. Yi and xi are the outcome variable and the explanatory variable for the i's observation. We can also express the observation in terms of its fit value and residual as yi equals beta 0 hat plus beta 1 hat times xi plus mu I hat. The former is the population model, while the latter is the estimated model. Comparing these two equations, we find that the error term mu is in the population model with the population parameters beta 0 and beta 1, while the residual mu hat appears in the estimated model with the OLS estimators beta 0 hat and beta 1 hat. The population model represents the true relationship between x and y. The estimated model is what we estimate from a sample we collect. We never know the population equation, but we can estimate it using a sample and a suitable estimation method to obtain the estimated equation. In other words, we never know the population parameters beta 0 and beta 1 and the error term mu, but we can estimate them using various estimation approaches, such as the ordinary least squares OLS estimation method. We hope that the estimators beta 0 hat and beta 1 hat are as close to the true population parameters beta 0 and beta 1 as possible. In econometrics, the criteria is whether the estimators are unbiased or consistent estimators for the population parameters. Under 4 assumptions on the population model: linear in parameters, random sampling, no perfect collinearity, and zero conditional mean assumption, the OLS estimator beta 0 hat is an unbiased estimator for the population parameter beta 0, and the OLS estimator beta 1 hat is an unbiased estimator for the population parameter beta 1. We can also demonstrate that the residual mu hat is an unbiased estimator for the error term mu. This means the OLS estimated equation is an unbiased equation for the population equation. But keep in mind that the estimated equation is not necessarily an unbiased equation for the population equation. For example, if the zero conditional mean assumption is not satisfied, that is, the error term is correlated with the explanatory variable, then the OLS estimators are no longer unbiased estimators for the parameters in the population model. The population model is the true relationship between the explanatory variable x and the outcome variable y. We can think of it as a data generating process by nature that produces all data. We collect a sample of the data and estimate the parameters using specific estimation methods, like the OLS. Stata provides functions to generate pseudo-random numbers, so we can use the data generating process to simulate a true relationship between x and y, as in the population model. In other words, we can set values for the population parameters beta 0 and beta 1. Then we use the OLS method to estimate the parameters and see whether they are close to the values we set. To be clear, for the real-life data, we never know the population model or the data generating process. However, for simulated data, we can set the population parameters by the data generating process so that the data have specific features. For example, we can set the population model as y equals 3 plus 2 times x plus mu, and the explanatory variable x and the error term mu satisfy the zero conditional mean assumption. Then we use OLS to estimate the relationship between x and y. And we find the OLS estimates are close to the population parameters we set. Specifically, the OLS estimate for the intercept, beta 0 hat, is close to 3, and the OLS estimate for the slope, beta 1 hat, is close to 2. The residuals also have a sample average that is close to the error term mu we generate. Today, we have explored the difference between the population model and the estimate model, and the difference between the error term and the residuals. Thank you so much for watching this video. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.